We're doing all of 7.4, and it actually includes a little bit from 7.1 that I skipped, so that's always fun. All right, so we are going to solve some equations today. We're going to solve a differential solve differential equations. That spells diff. Solve differential equations. Whoa, diffy Q's. Okay. Here we go. 2 types today. Diffy Q's, differential equations. So we called it. You take a whole class. After you take Calc 1, 2, and 3, you take diffy Q's.
Wow.
Differential equations. Mm-hmm. It was a pretty hard class.
I think calculus placement.
Ooh, do it. Tell me how you do. Is it online? Let me help you. Just kidding. Just kidding. I'm not going to help you. I don't do that. Nope.
I'm having Cortez help me with my Spanish.
No. All right, here we go. Differential equations is when you have an equation involving a derivative, okay? So there are pretty much 2 types of these for one variable. The first type is when you are going to find all the functions, and you've done this already. You're going to feel like this is the same stuff you've done all along. So here's what it says. Find all functions y.
This plus C, right?
Yeah. Find all functions y that satisfy this equation. And this is going to feel, this is going to feel like you've already done this. Satisfy this. Dy dx equals, I'll give you some fun ones though. Tan x plus x, no, I'm sorry, erase that. I was giving you the answer. Don't get mad at me, Kevin. Sorry.
Okay, I'm writing pen right now.
Oh, whoopsie woo-woos.
Why don't you do math and pencil?
All right, dy dx equals, I was looking at the answer, so now you know the answer. Secant squared x, I could have left it, but no. 2x plus 5. All right, so this is called a differential equation because it has a derivative equals to something, and we have to find out what y is. But all you're going to do is just pretty much integrate both sides, right? The integral of dy dx is just y. So you're going to find the antiderivative, and when it asks for all functions, you're going to write plus c at the end. Okay? So what is the antiderivative
Tan
of
x plus x plus c.
Oh, almost. Tan x
Plus x dx.
plus x squared.
Oh, antiderivative.
Mm-hmm. Plus 5x plus c. Okay? So that shouldn't feel different or new or really anything. And then you can always check your answer. If you wanted to find, you would just take the derivative and it should equal that. And it does. Okay. Now the other type is to find a specific one. Okay? So these are the 2 easy ones to kind of just do a little icebreaker today, and then we'll get into the harder ones. So this one right here is to find the particular function or solution to dy dx equals e to the x minus 6x squared, and then it says whose graph goes through 1, 0. Nope. Whose graph goes through the point 1, 0. Exactly. We've already done all this. We did it a while. I wasn't here for that day, and then you did it. Yeah. Okay, so we need to find out what y is. Y is going to be the antiderivative. It's if we take the derivative of this, it should equal that. And then we're going to do plus c, but then we're going to have to find out what c is because they give us this xy point that we're going to go ahead and plug back in and then solve for c. Okay, so that's the game plan. All right, so what's the antiderivative of e to the x? E to the x, good. And negative 6x squared is? Good, negative 2x cubed, and then plus c. Okay, but we want the particular solution. This is all the solutions, but we want the one and only one that will go through the point 1, 0. So you plug 0 in, 0 in for y, and 1 in for x. 2 times 1 cubed. And then, yeah, just leave it in terms of e. And so we're going to solve for c. So c would then equal 2 minus e?
Yeah.
So c equals 2 minus e. Once you do the whole thing, you bring the e over. And then this is just 2 times 1 cubed, which is 2. Add 2 to the other side. And then go back and plug it into your answer. So this c right here, you're going to plug it in to there. And you should get y equals, yeah, just leave it in terms of e. We don't want decimals or anything. E to the x minus 2x cubed. I would probably write minus e plus 2. And there it is. That would be your answer. Okay, so none of that should feel that new, right? That was actually in lesson 7.1. That's why I skipped it. But I wanted to do it because what we're going to do here is going to be a little bit harder. Do you want another one of those, or you feel okay? Okay. So let's do part B then. Part B is going to be a little tougher. So these are called separable. I don't think that's how you pronounce it. Separable. Separable. There's some words I just cannot say. That's one of them. Separable. I just did, huh? I said it. Okay. I can never say it right on the first one. Differential equations. Differential equations. Do we have time? We have an hour. Oh, no, you weren't talking to me. I'm sorry. I thought you said, do we have time?
Yeah, do we have time?
Okay, here's what separable differential equations look like. We're going to have, dy dx equals, but we're going to have two functions, okay? And one of them is going to be in terms of y, f of y, and the other one is in terms of x, g of x. And it gets really complicated. It's like two variables, okay? And what you want to do is you want to separate the variables. So you want all the y parts together and all the x parts together. So what we're going to do is we're going to bring the dx over to this side, and we're going to divide by f of y, okay? So you want to rewrite this like this. It depends. I like to write it as 1 over f of y times dy equals g of x times g of x times dx. Do you see what I just did? All I did was I took f of y and divided it over to the other side. You could write dy over f of y if you want to, and then dx times the other side. And what you do then is you are going to then solve for y. You're still solving for y by differentiating both sides. Solve for y by anti-differentiating both sides. Sorry. Both sides. Okay? Sometimes it's hard to write down some rules and then you don't have a real example, but once you see an example, it might not be so bad. They get kind of complicated, though. Okay, so here we go. Number 3. I skipped 3. Number 3. We're still trying to solve for y, okay? Solve for y. And it's going to be a derivative equation, so we have dy dx. Yeah. dy dx equals, and we're solving for y, and they're going to give us numbers too, okay? dy dx equals xy squared, and we're going to solve for y when y equals 1 and x equals 1. They could put that in points. I don't know why they don't. Okay, so it's going to go through the point 1, 1. All right, so we've got x and y. It's almost like, remember when we did, what was that called? Implicit differentiation, where you had to go dy dx, and you took the derivative of x, took the derivative of y, and it was, derivative of 2y was 2 dy dx. It's kind of like differentiation like that. All right, so we're going to split this up. So we have, what's in there? You got a bunch of cans in there? Because I really need them. Oh, there's one on the ground. Recycle that, please. All right, so we get dy dx equals, and we can split this up. We can separate this into x squared, y squared. Okay?
Is that the same thing?
Mm-hmm. Yeah. Exponent rules. Not if it's plus. There's a plus in the middle, it's not. You'd have to FOIL it. But this is just, yeah, x squared times y squared. All right, so let's go ahead and divide by y squared and multiply by dx, okay? So we get 1 over y squared dy equals x squared dx. And so basically right here, this step is where you're going to, see how there's a dy and a dx? You're going to take the integral of both sides, okay? So you're going to rewrite this as the integral of 1 y over y squared dy equals the integral of x squared dx. And then we're going to solve that. Now, I can't stand it when it's 1 over y squared. I would rewrite this as the integral of y to the negative 2 dy, which is good because we're integrating y dy, so that's really good, equals the integral of x squared dx. So all I did was rewrite it as to the negative 2. Okay, so let's go ahead and find the antiderivatives on both sides. By the way, you only need plus c on one side. You don't need it on both. It would cancel each other out anyways, but you just need it on one side, and we're going to always put it on the x side, okay? So what's the antiderivative of y to the negative 2?
Negative 1 over y.
Yeah, negative 1 over y, okay, because this was, you would add 1, so you get negative 1, but then divide by negative 1. So it becomes negative 1 over y, and that's equal to, the antiderivative here would be, perfect, x cubed over 3, and then plus c just on one side. You only need one c.
Which side?
Okay.
Which side?
Oh, always x. Yeah, so we're trying to solve for y. You don't want to make that side complicated. You want to just put it over here. So now we're going to go ahead and we're going to find out what c is, because we have a specific point that they gave us was when y is 1, x is 1. So we'll go ahead and plug both of those in and solve. So plug it in for x and y. They're both the same. So it's negative 1 equals 1/3 plus c. So c would equal negative 4/3. Okay, we're going to go back and plug that into here. So we have negative 1 over y equals x cubed over 3 minus 4/3. Okay. Now we have to solve for y. Pretty gross, right? So let's go ahead and multiply both sides by negative 1 so we can at least get rid of that. So we have 1 over y equals, and did you see this? You could actually put a negative x cubed plus 4, and all of that is over 3. Are you okay with that step? Just multiplied both sides by negative 1, and now we have to solve for y. So you can cross multiply if you want to, or you can just flip it. Do you see that? If it's 1 over y equals that over that, just if you want to solve for y, you just flip it. You can do that. That's a nice little shortcut. So then y would equal 3 over negative x cubed plus 4. There you go. So I took that, flipped it, flipped that. That's going to work just fine. Pretty good. Not too bad. If they get more complicated, let's do another one. Okay, number, what are we on? 4. I've got 2 more.
Number 4.
I skipped number 3. I know, but I skipped 1. Because you guys said you were cool with just one variable.
We have 3.
3?
Number 4 and number 5.
Oh, nope, we just have 4 and 5 since I skipped number 3. All right, we're going to solve for y again. And they tell us that dy dx is equal to cosine x e to the y plus sine x. Holy moly.
I have parentheses on cosine because I always use my c when my graph. think it's my C.
Oh, right. It's a big parenthesis. Okay, and then they tell us that, and y equals -1 when x is 0.
So 0.
Yeah. That's the way the book writes it, so I wanted you to be aware that's how they write it. I would have rather have written, you know, a point, 0, -1. All right, so write that down. This one's going to be pretty complicated. I had to work through this one a couple of times. All right. So first of all, let's go ahead and let's split this up a little bit here. We've got to get the x's together and the y's together.
We can't.
We can. I'll show you. dy dx equals, so this is cosine x, and this is e to the y plus sine x. Do you know what that equals? That equals e to the y times e to the sine x. Because do you remember? Your properties. Your exponent properties say when you multiply two things together, what do you do to the exponents? You add them. So all I did was like take that property and split them up. Okay? All right, so now you can see I have like 3 functions here. I'm going to keep my x's all together and the y's go to the other side. I'm going to divide and I get 1 over e to the y dy equals cosine x times e to the sine x dx. Okay. You're not going to need natural log in this one at all. Oh, you wanted to take the natural log of both sides? That'd be fun. No. Okay, so here we go. We're going to integrate this now, both sides. We're going to integrate this, and I'm going to rewrite this as e to the negative y dy equals the integral of cosine x e to the sine x dx. All right, now, this one's not so bad, this side, right? This one is the antiderivative e to the negative y is itself, and then divide by -1, which is just negative. Okay? Equals. Now we have to take the antiderivative of this. Some of you might be able to see it. Some of you might need to use U-substitution here. U-sub? Okay? Yes. Some of you guys might go, okay, you can kind of figure it out. Like if you took the antiderivative e to the sine x, you would do e to the sine x divided by cosine x, right? Because it's like anti-chain rule, and then the cosine x's would have canceled out. So it's just e to the sine x plus c. No. Okay, so if we don't see it, we're going to go ahead and use U-substitution. That's why it makes it so hard, but you know how to do U-substitution. So here we go. Change colors. Let u equal sine x. Okay. So we're going to take the integral of cosine x e to the u dx. But we need du. So du equals what? Cosine x dx. Remember U-substitution? It was last week. And then dx would be du over cosine x. No, it's the derivative. So du over the cosine of x equals dx. So I go back over here and I substitute it in. I get the integral of cosine x e to the u, du over cosine x. Then they reduce. Now that you know U-substitution, they're going to give you problems that involve U-substitution. It's like the U-substitution's in the problem you're actually trying to do. So then this would be e to the u du. So let's go ahead and take the integral of that, which would be e to the u plus c. Don't forget to take that u equals sine x and plug it back in. Okay. So all of that tells us that this would be e to the sine x plus c. Is everyone okay with that? After all that? So we did U-substitution over here to find out what the integral of this was. Or you could just try and think of it. I know that's hard to do because you're thinking backwards. What's the derivative of e to the sine x? It's e to the sine x times cosine x. There it is. That's it. Right? If I'm thinking anti-derivatives, anti-chain rule, I'm thinking, okay, I would take the derivative or integral of e to the sine x and I would divide by cosine x, and those would reduce and give me that. So, all right. Now, we got to solve for y still. Well, first we solve for c. Let's solve for c. Okay, so what was the point I gave you? I gave you the point was 0, negative 1.
Yeah.
All right, so we got negative e to the negative 1 would be negative e to the 1 equals e to the sine 0. Do you know what the sine of 0 is?
1.
It's not. It's the other one. 0.
Wow. Okay, I'm done.
Plus c. Thank you. And so you get negative e equals 1 plus c. So c would equal negative e minus 1. Are we okay with that? Yep. Take that, plug it back in up here. So now we have negative e to the negative y equals sine x minus e minus 1. And now we have to solve for y. Yeah? E to the sine x. Oopsies. Thanks. We're going to in just a minute. We got to divide by negative 1 first.
Yeah.
What was it? E to the sine x, right? Yeah, there we go. Okay, so yeah, you can go ahead and you can divide everything by negative 1 just to get rid of that negative right there. So we have e to the negative y equals negative e to the sine x plus e plus 1. Yes, now we're going to take the natural log of both sides because we're solving for y. So natural log of e to the negative y equals natural log negative e to the sine x plus e plus 1. And because you took the log of both sides, you can bring that negative y down. And we all know Lenny. He's 1. And then finally, you're going to just divide everybody by negative 1. So just put the negative in front of the e on the other side. So y would equal negative natural log of negative e to the sine x plus e plus 1. That was a problem, wasn't it? That involved algebra 1, algebra 2, trigonometry,
Like the one time you're not paying, or no, all the time you're not paying attention.
derivatives, integrals, U-substitution. That problem, if I gave that to you as your final exam, here's the one problem. Here it is. Do it and you pass or fail. You have an hour and a half to work on it. Good luck. No calculator. All right. All right, let's try one more, just because these are so fun. Last one, Trevor.
It's tedious.
They are. They're horrible. How many did I assign? 20?
Yes.
No, I didn't assign 20.
You did?
Did I assign a lot? I might need to look through those. There might be too many. All right, we'll find out. Okay, here we go. Last one. Dy dx equals. This one's pretty fun too. 8? Oh, that's not bad. And two of them are really easy. All right. 4 radical y natural log of x over x. Okay, we're going to find out what y is. So the derivative is this whole thing. We're going to find out what y was at the beginning, and y equals 1 when x is e. So the point would be e1. Okay, here we go. Let's go ahead and we're going to split this up. We're going to get our y's over to the other side, leaving our x's. So I would divide by radical y. So 1 over the square root of y dy equals 4 times the natural log of x over x dx. Is everyone okay with that? You have to separate your variables. Get your y's to the other side, x's all stay on the other side. And then usually like that 4 could have gone over here. It doesn't matter where it goes. I usually leave it with the x's because I'm trying to solve for y at the end anyways. So you don't want to make that side more complicated. All right, so now let's integrate. So we're going to take the integral of y to the negative 1/2 dy. And then over here, you can pull the 4 out to the front. The integral of the natural log of x over x dx. I wonder if we wanted to leave that 4 in there or not. No, I guess not. Okay, so now what we're going to have to do is we're going to need to do U-substitution again. All right? It's good to practice anyways. So this side's no problem. Let's go ahead and find the antiderivative of y to the negative 1/2. So you're going to add 1, and you get positive 1/2, and then divide by 1/2, so that would be 2y to the 1/2. Are we all okay with that? 2y to the 1/2. Now over here, we're going to use U-substitution. Now, I would probably, to make it easy on you, I might write at the top of this, let u equal the natural log of x, just to kind of help you a little bit, because you might get stuck on the U-substitution part. All right, so here we go. If we let u equal natural log of x, then let's go ahead and find out what du is. So du would be 1 over x dx. And then you're going to solve for dx by multiplying. So then x du would equal dx. Then you go over here and you have the integral of u over x times x du. And then the x's will reduce. And then that's when you're like kind of glad because you're like, whoo, sweet. So now you have the integral of u du, which is, what's the antiderivative of u? U squared over 2. Then don't forget to plug back in the ln x in here. And so over here we get 4 times u squared over 2 is 2 natural log of x squared plus c. Okay, now if you don't trust yourself or you don't believe yourself, you can take the derivative of this. The derivative of this would be chain rule. You bring the 2 down, that makes 4, leaving the inside alone. And then what's the derivative of natural log of x? 1 over x. That's how they get 4 natural log of x over x. Okay? All right, so now let's go ahead. Let's keep going. We're going to plug in e for x and 1 for y. So we get 2. 1 to the 1/2 is just 1. The square root of 1 is 1. And then we have 2 times Lenny squared plus c. Lenny, of course, is 1. 1 squared is 1 times 2 is 2. 2 plus 2 equals 2 plus c. C is 0. It's kind of fun. C is 0. Okay? All right, so let's go back up and plug 0 back in. So now we have 2y to the 1/2 equals 2 times the natural log of x squared. You could, if you wanted to, write that 2 in between the n and the x if you wanted to there. Okay? And the rest is just solving for y, which is not that bad this time. So we'll divide both sides by 2. Those are gone. And then you get y to the 1/2 equals the natural log of x squared. And then we're solving for y, so we want to square both sides, because that's the square root of y. So we'll square both sides. And a squared to a squared is a 4th. So y equals the natural log of x to the 4th power. Ooh, that one's clean.
When you do an exponent to another exponent.
You multiply. Yep.